Find this out and tell me the answer. We have already done the part A. You find out the part B and tell me the answer.
Power into I.
Okay.
Power is equal to V into I. So how much volt is that?
Electrical energy, right?
Upon amplitude A. Amplitude A back over that. I just look at which is the volts here.
Ammeter A reads 0.5 ampere here. Okay. How much electrical energy is changed to heat and light lamp L1 in 1 minute? So this one. This one, what we need? We need to find out first the amount of charge that needs to be moved, right?
Yes.
So amount of charge that needs to be moved is I into T. So I is 0.5 and time is 60 seconds. 1 minute means 60 seconds. So we basically have here 5 by 10 into 60. So that becomes 330 coulomb. Right? So 30 coulomb into, then we have electrical energy E equal to V into I into T. So here V across L1 is what? It is 12. 12 into 30. So that is 360 joules.
Oh, okay. Wait. 12 into 30? It's 9 right now.
This one is 30, right? We have
I see. Okay, if that's right, then I think so. Okay, that's another one. Instead of power, it's 9 and also.
Yes.
So, it's a coulomb.
Yes.
Oh.
So, problems are very problematic, right?
Yes. Okay, now let's see the C.
Yes, now the C part.
Solve the figure E618 and mark A plus the positive.
Mark positive for positive terminals of ammeter and voltmeter. Now we have a positive terminal here, a negative terminal here, a positive terminal here and a negative terminal here. So negative terminal of the battery is connected to the negative terminal of the ammeter and the positive terminal is connected to the positive terminal of the battery. So here what will happen? The positive terminal, here we have the positive terminal, negative terminal, positive terminal, negative terminal. Clear? Okay. Can we just take a new page? You want to take us?
Wait. One side of here is positive line. Here is negative line.
Okay.
How does positive come
Because this part is the positive terminal. So it says the positive part will be connected to the positive terminal of the battery. Since we are considering the terminal of the battery, we are not considering anything else. So always the positive terminal will be connected to the positive terminal and the negative terminal will be connected to the negative terminal, right? So here we have the positive terminal end. So here only we have the positive terminals. Here we only have the negative terminals.
that I can map, but with L1 and L2.
Yes.
This side is L1, how much is negative? And this side is positive 5 because in this way.
So once we have connected the positive in one direction, the negative will automatically go to the next end. So here it will be negative.
Oh.
Right. We have to connect both the terminals. We have a voltmeter with a positive and the negative terminal. We have found out where to connect the positive. So we know now where to connect the negative. We have only one location left.
It's done, but
Done?
yes,
Can we move on to the next portion?
yes, ma'am.
Okay. Next portion is I'll give you a tricky question. A tricky question, which you need to find it out. Okay, it's a mixed bag question. I'll just tell you to find out the resistance through this. Like with this, I think we will be done with all our doubts and everything. So no more doubts will be.
In this chapter?
Yes, this is the last bit. The chapter questions are all done. So only this part I have taken it from somewhere else. Though this is an IGCSE question only, but I have taken it from somewhere else. I'll just put the question here because due to lack of time I couldn't take down the screenshot of that. I don't know how the screenshot vanished. So I'll just draw it and I'll let you know. You have to find out the total resistance, that is all, and the current. Okay, so this is the question, right?
Well, actually, ma'am, it's the link that I sent you.
Yes.
There's also a question and Facebook.
Is it? Okay, I'll just check it. I'll just check it. What you do is, why is this coming? I don't understand. Wait, beta. Just let me check.
This is one question.
This
What
is.
are the voltmeter readings?
I'll just find it out. What are you saying? First, you let us do with this one. I'll figure it out. That.
Yes.
I'll just see that first. Just a moment. I'll first draw it, okay, and then I'll screen share. Okay, I have drawn it and I'll just screen share it. This, you have to calculate the total resistance and the current. Okay, will I proceed with it? So first draw. We have to draw it in different portions. So the draw one, or I better say redraw one. Okay. Because I have to redraw this structure. Okay. So what I am basically doing, as you can see, I have made 3 junctions here for me to draw it properly. Okay? Okay, so if I mark this as my junction 1 or J1, then what I am getting is, see, by this junction I have various things. The first thing that I get is I have a 50 ohm connected to a 250 ohm. So that completes and brings me to junction 2. Right? Okay. So in this junction 1, I have another section which is the 100 ohm. Okay. Now in between junction 1 and junction 2, I have a 200 ohm. Okay. I give this junction a 0 ohm. Nothing is here, it is just a line joint, so I write 0 ohm. Okay. So junction 2 and junction 3 are connected by 0 ohm. Right. Junction 3 and the first junction is again there. We have a 50 ohm. So that brings me back here again, right? So is the circuit complete?
Yes.
So first we'll calculate the resistance here by this way. So here what we find, this is a series circuit. So the resistance here will be 50 plus 250, that is equal to 300 ohm. Yes? And sorry, I forgot that this in the junction 1 and 3, I have again a 300 ohm. This one. First you draw this figure out, the first figure, and then you redraw the second figure, otherwise you will confuse. You draw along with me and then it will be okay. Okay, have you drawn it somewhere?
Yes, ma'am, I have.
Okay, so next we'll draw the next part, that is the redraw 2 now. So this is our redraw 1, we'll go to redraw 2. I hope my pen colors are okay. Yes, redraw 2. So here I am just putting 100 ohm as usual because nothing was calculated. Instead of this 300 ohm, 250 and 150, I'll just put a 300 ohm here. Yes, because I've already calculated that to be 300. We have a 200 which was already there. Right?
Yeah.
And a 0 ohm was here. Sorry, and a 150 was here. Right? So beneath this we had our junction 3 here. We had the 300 here. Right?
Yeah.
So again we see that these two are parallel. So we will calculate this first. So 1 by 300. 1 by 300 and 1 by 200, it's like 300 into 200 by 300 plus 200, right? So it is 500. So it's like it is coming to as 120 ohm, right? Calculate and confirm. It is 60 into 2, so it is 120, right? So it is coming 60 into 2. It is 120.
Oh, you have to cancel it and then.
Yes.
Oh, yes.
So that is 120, right? So I'll redraw it again. It is just you redraw it and you make the circuits shorter and shorter, you'll get it. So here instead of this 300 and 200, I just simply write a 120 ohm here. So that completes my junction 1 and junction 2. Now I get a 0 ohm here and a 150 ohm here. Right?
Yes,
Okay.
and then below that,
Yes. So below this I get a 300 here. So what I simply do is, this is my junction 3. So this is simply what? It is 120 ohm.
120.
And this is a 300 ohm. This is in parallel with this. So 120 parallel 300 gives me 86 something. 86 ohm. Okay, we can figure that out. Like,
Okay.
I'll just work it out for you. 120 into 300 by 120 plus 300. So that is 120 into 300 by 420, right? So this 12 and this 6 2s are 6 7s are. So that brings us something like 600 by 7. So it is coming to how much it is coming? 85.7, something like that. 85.71. So we take it as 86 ohm. Yeah? Yes, Shakti? You just tell me when it is clear so that I can confirm and go to the next part.
Yes, now it is clear.
Okay. So next I'll just take another color. I'll take the red yellow color. Okay. Now this is redraw, my last redraw, which is 4th redraw. Okay, in this redraw what I do, instead of all these things, I'll just put 100 ohm here, and this entire thing I have calculated to be 86, so I put a 86 ohm here, and I have a 150 ohm here.
And 150.
So that gives me,
So 100 plus 86 for 150.
that gives me 336 ohm. So my result, yes. So we are done.
Yes.
Okay, next part is just calculating the current through this entire circuit. Okay, so I bring this part here, and instead of all these haywire diagrams, I'll just put a 336 ohm here and an 18 volt here. So that gives me the current as V by R. Now V is 18 and R is 336. So that will give me 0.054 ampere. Done? You want to take a screenshot? Will I give you a screenshot like that? Or you want me to give you this entire thing as a folder? As mail, you want me to give this? Okay, so what I'll do is I'll just write it as redraw 5 here. So,
This is for my reference.
yes, so what I'll do is I'll just mail this to you. So I think you will be able to understand.
Yes.
Okay, so I'll mail this to you. So I think,
This is where our PDF.
yeah, so for today we are done, I think.